Okay, so I'm recording class. What was saying before that, for the people that were not attending the class today, was just a review of what we already discussed on the first class. So nothing essentially new. I also saw that we are speaking about the lecture videos. The lecture videos are on YouTube. So we have a YouTube channel, and I don't know, you don't, in principle, you don't need to enroll to the channel or subscribe to the channel. You just watch the videos that are there. And I put all of them. I already included also the one of the next week. So some of the students were asking me, should we come to your lectures and after we have seen the lectures or before? This is really up to you. So if you watch the lectures before, this is going to be just a review, or you can ask questions. If you are not able to watch the lectures before my class, it will be like, yeah, some appetizer, let's put it this way, of what you are going to see in the lecture. So it really depends on your schedule and how you feel better about this. There is not a unique instruction for that. And what else? I think this is pretty much it. So
yeah, I'll just remind everyone that although homeworks 1 through 3, mastering physics, is technically 2 assignments, homework 1 and 2 and homework 3, because homework 1 would have been super short. Although it's technically due next Friday, 2 things. Don't wait until next Friday. Right after you watch the video, review some of the tutorial problems, do it immediately. That way you have a few days to drop in and see our learning assistants with any questions or ask us questions about that material. Number 2, there is no late homework allowed. So Friday at 11:55 p.m., the assignment will close, and that's it. So you'll get credit for any problems that are submitted. So you don't need to submit an entire assignment. Any individual questions or problems you've answered, you'll get the credit.
very good. Yes, this is important. You can submit anytime before, but not after. If it's after, then you just get 0 points for that assignment.
I see that 170 of you have already joined Mastering Physics. So great. And a lot of you have already started work on the homework 1 through 3. Homework 0 in Mastering Physics and Intro to Mastering Physics, whenever it says not for credit in big capital letters as part of the assignment title, then that means all of the problems in that assignment have 0 points. So you can do as few or as many of those as you want.
Okay. And indeed, yeah, there is somebody that we're expected to watch the lecture before class, right? So again, it depends. It depends how you prefer to do it. You will see there is not a, if you watched before, of course, is ideal. Like this, you come and you can ask questions about that topic. If you cannot manage, it's fine, as long as you keep the pace that we provided. So you have to watch these videos in this week, because otherwise then they pile up all together with other new videos. You know what I mean? So this is something you don't want to do. Are there other questions? Will the not for credit assignment stay active through the entire course?
I'll answer that. Yes. Short answer, yes. In fact, all assignments should still be visible to you. And you can always choose a button that says rework for practice for any assignment and any problem in any assignment. Ones whether you've done it or not.
Yeah, and also, do the assignments close after we submit them? Can we go back through them to review them? Yeah, I think they're still visible, right?
Yeah, so I think I just answered that. Yeah.
Yeah, okay.
Right. So yes, all assignments should remain visible to you for the entire semester, whether you submitted answers for them or not. And even if you have submitted an answer, there's a button that says rework for practice, which is no additional credit. But yes, so all assignments should all be visible to you for the entire semester, which is good for final exam study.
Okay, awesome. Thank you. I've done the student too. Yes. Asking twice the same question. Okay. Okay. Any other questions about logistics, about any of these things? Please, this thing is actually pretty good, because is in the chat. So we can answer even later, so from this point of view, it's easier than when we do lectures in class. So if I change and go back here, are you able to see the new screen, right?
Yes, great.
So again, let's review the lectures for this week. So the first one, lecture 1A, is essentially the introduction and all the things we already discussed last time. So all technical things, how to get to your assignment, to mastering physics, to home, how much is the homework, when is going to be the exams. Please, again, keep in mind, last time we discussed it already, the exams, we are going to evaluate 4 out of 5 of between the midterm, the 4 midterms and the final. We are going to remove the lowest score for you, but there are no makeup exams in any circumstances. And I want to stress that because sometimes we receive emails with tragedy happenings or whatever reasons. We cannot do it. We cannot do it. It's just there are no any circumstances that you will have an extra midterm or a different final. And then what else we said? Something that we need to say now? No, so essentially, yeah, where the tutorials and solution are located, the course grade, and again, we said in the syllabus, there is the formula, how to calculate it. Now it doesn't make any sense, but when you're going to get closer to the end, you maybe want to know it. Those are recitation, and the recitation will be described, plenty described at the first recitation, and then the calendar, which we said is your first go-to guideline. Okay, this was essentially how to get help with physics. So don't forget that there are all these resources for you with people that can physically help you in if you have problems. And those was pretty much also the lab that has nothing to do with us. So please ask the questions about the lab, keep it for the lab, and where to find the syllabus. Fantastic. This was the first lecture. Then the second lecture is about metric units, metric prefix, analysis dimension, unit conversion. And you have also tutorials associated with it. And as we said, also the homework. So units, let me review some of the topics. So I assume because you are here that you have already you already know what a unit is, and you have already working with this type of information, with this type of things, but we just want to emphasize which one are going to be the mostly used during this course. So we are going to have a length and distance, which is meter or centimeter. Then we are going to have time with seconds, mass with kilograms or grams, depending on the unit system, and temperature, which is Kelvin. Unfortunately for me, because I'm Italian, and in Italy we use Celsius, and so it's very much confusing for me, the temperature system here. So these are called fundamental units. And so here we put in the lecture some of the questions that you need to try to solve. And then there is also the description. And so you can definitely understand a bit better and give a meaning to these units. So I'll not go through all these things because I believe you already know all of them. So what is going to be important is so, for example, here we have fundamental units for time is seconds. So you have, of course, you need to know how many seconds in a minute, in an hour, in a day, in a year. You need to be able to calculate these things, but I assume you are able to do it. And then here there is, for example, the difference between mass versus weight. This is very important because it's a sort of misconception. So the mass is the amount of matter on an object. So it doesn't really change. Rather, you are here, you are on the moon, you are on Mars. It doesn't really change. While the weight is the strength of gravitational force acting on a mass. So by a planet. So this is what really changes. So if you are here in the surface, or if you go with Jeff Bezos in one of his travel, suborbital travels, your weight is going to change, right? Your mass is not going to change, but your weight, yes, because it's a force, it's not the amount of matter. What is extremely important is the dimensions. Dimensions for me is what really are important, because they give you an idea also if you are making some mistakes or not when you make your calculations. So for example, the speed is a length over time, right? If we calculate the speed, kilometer per second or miles per hours, you know from everyday life that is has these dimensions. So when you make all your calculations in your problems, if you see that the dimensions are not correct, if you find out the speed, which is only a length, or it's only a time, then something is wrong. Or is a length square over a time, something must be wrong. So you need to really pay attention to the dimensions. And so, for example, here we have and we can, how can we use them? Are derived by multiplying and dividing combination of base units. So you don't really look at the number. It's like you're doing the problem, not looking at the number is 10 or 5 miles per hour. I don't care now if it's 10 or 5. What I just look are the dimensions, and I can do exactly the same multiplication and divisions as you will do with the numbers, but this time with the dimension of a quantity. So for example, density is mass over volume, which means mass over a length to the cube. And so, yeah, here, for example, we have in MKS units for the speed meter per second, while for the density, we have kilogram per meter cubes. And then, for example, pressure is a force over a defined area. So in this case, the force is mass times length divided by a time to the square. We will review these things. And the area is a length to the square. So it's very important, as we said, that you do a dimensional analysis, and they help determine the nature of an unknown quantity, and you can catch errors in formulas or problem solving. So here there are some examples that you can do at home and look at home, and maybe we can look at them later if we.
I'll just add also for everyone who's in the lab class, you'll be doing a little bit of dimensional analysis during your first week of lab as well. Mm-hmm. And by the way, the labs don't meet until week 3, January 24th.
Okay. Then it says, for these things, practice with these tutorials. So it's very simple for you to follow all these things in a coherent way. Then we have a metric prefix, which is word letter attached to the front of a metric unit to denote the power of 10. So for many physics quantities, we really need big numbers. So trillion, billions, not only physics quantities. Here we could speak even about money, or we could even speak about, you know, all
if you're gonna go into medicine, then people's cholesterol numbers are micrograms per deciliter. So these metric prefixes between 1 trillion. Oh, and if you're a computer science major, you already know about terabytes and petabytes and exabytes. So these metric prefixes are essential to memorize for all of us who are in the sciences.
Yes, yes. I mean, even when you are in, when you're trying to define, if you want your hard disk, which is 10 gigabyte or 1 terabyte, you need to know the difference. Otherwise, you might buy the wrong thing or overpaid for something, thinking that 10 gigabyte maybe like for my son, you know, for 10 gigabyte for him is bigger than 1 terabyte because he doesn't know and he just see 10 and 1, and so for him is you know, something like that. That's why it's important to understand. So 10 to the 12 is tera, 10 to the 9 is giga, 10 to the 6 is mega, 10 to the 3 we all know about it, a kilo, 10 to the 2 is hecto, 10 to the 1 is deca. And then you have a 10 to the 0, which makes 0. And then you can go also to the extremely small, and this is also important for biology, for major, for also for physicists, because we look the infinitive bigs, but also the infinitive small. So you have deci, which is 10 to the -1, centi, 10 to the -2, milli, 10 to the -3, micro, 10 to the -6, nano, 10 to the -9, and 10 to the 10 to the -12 pico. And this is also very important for electronics. If you do electronic engineers, you have all this very, very small thing because we want to miniaturize stuff. So should we add anything else, Mike, on this?
Those we will use between prefixes between pico and tera. They will just appear in homework problems or exams without being defined or expanded. Right? We usually won't use the ones beyond that because those are a little more obscure and are used less often. So if that happens, we'll just spell it out times 10 to the 28, right? Something like that.
Yeah. So I think, no, there are some more. So here you have the practice tutorial for this, and then you have unit conversion. So unit conversion is also very important because if we want, what if we want to convert length in miles? If we have length, for example, in miles, but we want to convert it to kilometers, so we need to use a unit conversion. So for example, here 1 mile is 1.609 kilometer. And then again, if you put if 1 mile divided by 1.609 kilometers, they need to give 1, right? They give 1 because they are essentially the same thing. So if you do one after the other, they are the same thing. So if you this multiply by, instead of 1 mile, you want to understand how much is 24 miles in kilometer, you just multiply 24 miles times the unit conversion, which is this one that we just said. And again, we do a dimensional analysis. So you see the miles and miles, one is at the top, one is at the bottom, so we can cross them out. And so you end up having 24 times 1.609 kilometers, which makes roughly 39 kilometers. I think it's clear. If it's not clear, are there any questions?
I do have a quick question. So on exams and whatnot for conversions, are we expected to know the conversion ratio, or is that going to be provided?
That's an excellent question. So the answer is yes and no. You will not be provided with any conversions between metric prefixes, between kilo, mega, nano, micro, milli. That you should memorize, and you should be able to produce that on your own. I mean, look, our exams are open book, okay? So you could look this stuff up, but it will slow you way down. You only have 50 minutes to answer questions quickly. So you will be provided with anything that is like a miles to meters or miles to kilometers conversion, any British conversions, any unusual non-standard things like atmospheres to pascals that will be provided in the problem of the test. Although it is something, again, open book exams, it's something you could look up if you needed to.
Yeah.
Okay. Final question, final point. We are not collecting written or shown work on any problem sets or exams this semester. So all you have to do is enter a numerical answer or select a multiple choice answer. However, if we were, we'd like to see the conversion written out, but you will not need to actually write it out for us this semester.
Yeah. So here there are some other examples that you can work out, and you can see how they idea workout. I don't know if I need to do it. It depends if it's very clear for you or not. But so as you see, when we were discussing before with the dimension analysis, you see how they cross out when they are one at the top, one at the bottom. And then you end up with, for example, here you have 120 kilometers per hour. How much is it in meter per second? Okay, so kilometers is 1,000 meters. So I just substitute this kilometer, I have to multiply by 1,000 meters. And then you have an hour that is 3,600 seconds. So 1 hour over 3,600 seconds is 1. So you just put this conversion and this conversion here. And what you want to obtain is essentially that kilometers goes away and meters stays there. And like here, you want that hour goes away and second stays there, because you are looking for something that is meter per second. I don't know if this clarified a bit, but you will also do it in the lab, as Mike said. And those are other examples. I will not go through them. And you have, again, all tutorial with certain problems of this and the online homework too, related to these topics. Are there questions about this class, this lecture? If not, we can go to the second one. So the second one is about the significant figures, uncertainty and significant figures. So first you have a sort of review quiz, and please do it about what you've learned during the first class. And just test yourself before going to the following to see. And then we have precision and uncertainty. So Mike in the video will describe all these things. As you know, every time you make a measurement, essentially there is always a certain amount of precision that you can make a measurement, right? And so you have something is a limited precision. So you have something called like error that you normally should put always together with your measurements. Now, not in all the fields, they are so picky about the error that needs to be together with the precision, unfortunately. While for example, in field like mathematics, physics, and so on, it's required, it's necessary. For all our measurement, we have an error associated with that. So with the uncertainty. And how do you write this uncertainty? So here, for example, this is the uncertainty. So if I, for example, a diameter of a car axle, I can find that is 6.89. 6.89 is such a precise measurement. You are not saying is roughly 6 meters or 7 meters. If you would say this roughly 7 meters, then you don't need to put the precision that much, because we already know that your measurement is not the best one. But if you provide a number which is 6.89, I'm expecting you that this 9 you calculate it in a very good way, right? So because it's going to be different if y is not a 6.88 or y is not 6.90. So because of that, if you provide a number like this, I'm also expecting that you are going to provide an error associated with such a precise measurement. And this error needs to be of the same significant figure of the measurement. So here is 0.04 centimeter, which means that roughly you took several measurements, and once was 6.89, another time was 6.92. And so all these errors is between 0.89 plus 0.4 and minus 0.04. Then, so here, implied uncertainty versus significant figures, digits that are actually measures, 1 to 9, and 0 when it's not a placeholder, or in calculation, rounding off long decimal to reflect number of digits of the measured values used in the calculations. Are there questions for this type of thing? And Mike, are there questions that you want to share?
Well, I'll reply to something that someone asked in the chat. And there's sort of two answers to it. The question was, do we always give 3 sig figs to every answer? And the answer is no, right? In fact, as this lecture that you're talking about now goes on, it goes into detail about these sort of quote unquote rules for determining how many sig figs to report on a final result, on a final answer for a question, right? And there are rules about when you're adding or subtracting values, rules when you're multiplying and dividing values, and so on. So if you were writing out your homework problems to turn into us, or exam problems to turn into us in long form, show your work fashion, that's how you would decide how many sig figs to round your final answer to. Don't round intermediate values, carry extra digits on intermediate values, but final answer should be rounded to an appropriate number of sig figs following the rules that are coming on the following slides. That said, I need to add another caveat, which is Laulima, in its tests and quizzes questions, it's like a calculator. It treats every numerical value as a perfect number. So it will calculate everything to infinite significant figures. And we have to enter a tolerance of 1%, 5%, 3%, within which your answer would be counted as correct versus wrong. Okay. So this isn't sig figs, this is computer programming. And what I do is in all of our Laulima questions, I keep saying a reminder to you at the end of the problem, please enter your answer to at least 2 sig figs or at least 3 sig figs or more, so that Laulima won't count it wrong. This is not proper scientific practice. This is dealing with Laulima. That's all that is. Mastering physics, same thing. Mastering physics will accept any answer to within about 1.5 to 2% of what it thinks is the proper calculator value. And it'll count it. If it gives you the word correct with a green check mark, even if it whines about your rounding, you've gotten full credit, okay? Otherwise, if you're outside of that little 2% threshold, it will usually say incorrect, but you're close. And if you're way outside, like outside of 5%, it'll just say incorrect. All right, so I'm sorry, that's online learning garbage that we have to deal with, right? But so that's sort of the practical answer for this course. Don't do that when you get back into real life. Thank you.
So essentially here, for example, 6, you have one significant figure. Here, 6.0, you have 2 significant figures, right? Otherwise, they would have put only 6, not 6.0, if they wanted you to pay attention only to one significant figure. The same is here, 6.02, 3 significant figures, and 4 for 6.022. This is an example. And then there are rules for zeros. And also this, you need to learn these rules. So the leading 0 that comes before its decimal point is considered not significant. You need to learn these things. The leading zeros that come after a decimal point is considered not significant. So all these rules, you have to write them somewhere and memorize them, or make them clear to you when you're doing your midterm, so that you can find them easily and check in case you have some doubts. And then the same is trailing zeros that come before an unwritten decimal points. So you need to check all these different rules, and there are examples for that. And then for any set of values about to be combined with multiplication or division, find the individual value of the fewest significant figure and round the final answer to the same fewest number of significant figures. So if you have one number that has lots of significant figures, like 2.40s, and this one is 8.0, so you know that this one has one significant figure less than this one, so as the fewest number of significant figures, so your last number is going to be 3.3, like the same format of the first number, not of the number at the denominator, the same of the one with the fewest number of significant figures. For addition and subtractions, if round the final answer at the same highest decimal place, so 96.6 plus 7.2 gives 103.8. So we need this 0.6 and 0.2. You cannot remove that, right? Because it will be 103 milligram. It's wrong. Essentially, 103.8 is way more closer to 104 if you think about it. So you see that this 0.8 really makes a difference. So in this case, you have to round at the highest decimal place. And this is essentially here. There are some examples for making you understand a bit better how it works. And then there are the tutorials. And then are there other questions, important questions for this thing? The fractional uncertainty. So you need to see fractional uncertainties is like a division, right? You have one number at the top, one number at the bottom. So you apply the same rules as you will apply for a division. Then there is lecture 3. For lecture 3, we finally get into something that is more related to physics. So in lecture 3, we really focus on, so here at the beginning, you have a review about significant figure, where you can understand if you got it correct or not. And then we finally go to the first physics topic, which is position versus displacement versus distance traveled. So position, of course, you need to know how to draw a Cartesian coordinate system and have the Cartesian coordinate values, which are X or Y, or in horizontal and vertical, or if it's three-dimensional, X, Y, and Z. Then the displacement is the change in the position. The change in the position meaning from the final value minus the initial value. And this you have it in X, Y, and Z, and can be positive or negative because it's final minus initial. When you find initial one, sometimes it's also indicated with the 0 at the bottom and is pronunciated not. So X not in this case. I give you an example. So this is the displacement, and then, sorry, the distance traveled. The distance traveled is indicated with D instead of delta X or delta Y or delta Z, and is essentially like if you would do everything on a straight line path with no change in direction of motion. So can be only, because it's the magnitude of delta X, it can be only positive. So if an object reverses the direction, or if object's path is other than straight line, you have no standard formula to find D. You have to, is essentially all the mileage that you have done. Like distance traveled would be like the one that is counting your steps in your phone. It doesn't care if you did your steps going up the hill, going straight, coming back home, just count the number of steps. So this is the distance traveled, while the displacement is a different thing, and you'll see now. So let's start with an example that is also in your book here. So here you leave, the starting point is 0, but your car is in a position which is 90 meters from the starting point, and it gets to a final position which is 277 meters. So in this case, the displacement delta x is final position minus initial position, right? So 277 minus 19, it gets to 258. The distance in this particular case is exactly the same because, yeah, you did this amount of meters. There's not a difference. But in case with in the lower graph instead, what you see in the lower picture, you see that your track goes from the position at 277 meters to the position at 90 meters. So if we look at the displacement is going to be initial final 19 meters minus initial position 277. So the displacement is negative and is 258. And is actually telling something new than the distance, because it's telling you that it's going from one position back to the original position, because there is this minus that tells you the direction where the car is traveling, while the distance is exactly the same. It's just the amount of meters that this car traveled. So you see how they are different, these two concepts. And here we are going to have some problems about that you have to do. Then what we have is the average velocity. The average velocity is the slope of a curve. So essentially here we have x and here we have the time. So time one, we say that time one, my car is in the position x1. In the example of before was 19 meters. So at time one, my car is 19 meters. And then the car arrived at 200 and I don't recall, 266. I don't recall what was the final location. Let's assume 266 after a certain amount of time. So T1 here is not in 0. So it's telling me that T1 is 1 second. So at 1 second, the car is in position 19, which is x1. And after 4 seconds is a position T2, which are almost 300 meters. So I must have a very good car with a very high velocity. And the velocity here is shown by the slope between A and B. How do you find the slope? You just do the average velocity is delta x over delta t. So delta x, we said final position minus initial position. Delta t is final time minus initial time. And you look at the slope. You see that the slope here is increasing, which means that the velocity is positive, is increasing. If it will be stuck at 0, imagine here, with 0 velocity, you will find out that the car moves from, after 1 second is in the position 266, and after 4 seconds, the car is still at the same position. Can you see my pointer or not?
Yeah, it looks like a little crosshairs, but so it's not too big.
Yeah.
But yeah,
it's not too big. Maybe I can make it bigger, but so in this case, you have that the velocity is constant and is 0. So that essentially you are stuck. Now, in addition to the average velocity, you have also the instantaneous velocity. The instantaneous velocity is the derivative in that specific point, the derivative over time. And so is the tangent slope at that specific time. So you might have that during this time 1 and time 2, you go all the time at the same velocity, so which is the average velocity, or you might have that you go very fast at the beginning, a bit slower after. Here actually look like, yeah, the slope, you know, in A is like this, and so it might look like it's actually increasing the velocity, the instant velocity. And so the tangent is getting steeper and steeper the more I get into B. This is how essentially works. So average velocity, delta x over delta t, instantaneous velocity is the derivative. Both of those can be positive or negative because you can go with the velocity that is increasing or decreasing. The average speed instead is the distance traveled per time elapsed. So you take the distance that, remember, is always positive. Doesn't matter if you are going from the grocery store home or from home to the grocery store. This is the amount of steps you have done divided by the time it took you to do those steps. And here you have the average speed. The instantaneous speed is also the derivative, but is always positive.
Hey, Veronica, it looks like
Yes.
we are at the end of our time. I wanted to
Yes.
ask you if there's anything quick you wanted to wrap up with.
So yeah, I mean, it's you do all these things and you will see that it's pretty simple to understand this type of concept, although tricky, but they are very simple. Tricky in the sense that they are new. So there are subtle differences, but they are clear, the differences. And then what I want to add is the fact that on Monday, as you know, there's not going to be class. It's going to be Friday, next Friday. I'm going to upload this class where you have all the videos indicating what it is. And yeah, please do everything that you need to do, because next week you are going to have 3 additional lectures, which, by the way, I've already included in our YouTube channel. And all the material is already in Laulima. And have a nice long weekend to all of you.
Thank you. Take care, guys.
Thank you.
This is lecture 2A, correct?
Thank you.
Lecture 3.
This was lecture 3. Yes.
Okay.